Hi, Zakwan. Have you ever wondered how submarine navigation through the darkest depths on the ocean, where no light can reach?
The answer is sound, right?
Yeah, we are Group 3 and we are here to walk you through the science of sonar technology. Okay. Before we dive into the detail of our topic, allow me to introduce the team behind this presentation. I am Muhammad Nafizuddin and join me are my teammates
Mama Aidil and
Muhammad Zakwan here.
together we have worked to break down the complexities of sonar technology for you.
I would like to start with the introduction of sonar technology. Sonar technology is a fascinating tool that uses sound wave to explore the deep ocean. It works by sending out sound pulses and measuring their echoes as they bounce off underwater objects. By reading this reflection, we can determine the exact position, distance, and shape of anything hidden beneath the surface. Essentially, sonar turns sound into a visual map of the ocean floor, allowing us to see where light cannot reach.
First, on the left, we have active sonar. Think of this as shouting into a canyon and waiting for the echo. This system works by transmitting a sound pulse, often called a ping, into the water. It then listens for the echo that bounces back when that wave hit an object. It actively reaches out to find targets. On the right, we have passive sonar. This is a listen-only system. Instead of sending out signals, it uses underwater microphones called hydrophones to detect sounds made by other things like ship engines or marine life. It stays completely silent and does not transmit any signal itself. In short, active sonar sends and receives, while passive sonar only listens. Thank you.
Now, let's look at the specific difference between these two systems using the table on the screen. First, look at what they detect. Active sonar is powerful because it can find objects that are completely silent. Passive sonar, on the other hand, relies on the target making noise, like the sound of an engine or a propeller. Second, regarding component, active sonar is more complex. It requires both a transmitter to send the ping and a receiver to hear it. Passive sonar is simpler. It requires a receiver only, specifically hydrophone. Finally, regarding range accuracy, active sonar is very accurate because it calculates distance based on the precise time delay of the echo. Passive sonar is generally less accurate for range and often require complex techniques like triangulation to figure out how far away the target is.
Let's break the four main components that make a sonar system works. First, we have the transmitter. Its job is to produce a sound pulse, known as a ping, that is sent into the water to detect objects. Next is the transducer. This is critical component that acts as a converter. It converts electrical energy into acoustic waves when transmitting and turns those acoustic waves back into electrical energy when receiving a reflected signal. Then we have a receiver, as the name implies. It captures the echo or reflection of sound returning from underwater objects. Finally, the recorder. This process the data received and display the information usually in the form of image or visuals on the screen for the operator to analyze.
Let's walk through the 5-step process of how sonar works, as shown on the diagram. Step 1 is sound transmission. The sonar system uses a transducer to emit a powerful pulse or ping of sound wave into the water. Step 2 is echo-reflection. This sound wave travel until they strike an object like a submarine or a seabed. A small part of that sound reflects back as an echo. Step 3 is reception. The receiver or hydrophone detects this returning echoes and converts it into an electrical signal. Step 4 is calculation. A computer then measures the precise time that elapsed between sending the signal step 1 and receiving it. Finally, step 5 is display. The system processes this data to show the object's distance, direction and size on a screen for the user.
Let's look at the key application and advantages of sonar technology. Sonar is incredibly versatile and plays a vital role across several sectors. First, it is essential for navigation and marine safety, helping vessels avoid underwater hazards and travel safety. In the food industry, specifically fisheries and aquaculture, sonar is used to locate schools of fish and monitor underwater pens efficiently. Furthermore, sonar is cornerstone of military and defense, used by navies for surveillance and detecting submarines to ensure national security. Lastly, it is a powerful tool for underwater archaeology and object search, enabling researchers to discover shipwrecks, lost artifacts, and map the secret of the ocean floor. In short, sonar is not just about sound, it's an essential eye beneath the wave for safety, industry, defense, and discovery. While sonar is an essential tool for maritime navigation, it is constrained by several physical and environmental factors. First, the varying speed of sound, influenced by water temperature, pressure, and salinity, can cause sound waves to bend, leading to inaccurate depth of distance reading. This accuracy is further challenged by background noise, where sound from marine life, water, or other ships create interference that must targets. Beyond technical issue, there is a serious impact of marine life. High intensity sonar pulses can disrupt the communication, navigation, and physical health of animals like whales and dolphins. Furthermore, using active sonar creates a risk of location exposure, as emitting a pulse reveals the sender's position to others. Finally, range limitation occur in deep water because sound energy is naturally absorbed and scattered over long distance, which significantly reduce the system effectiveness in vast oceanic environment.
Overall, sonar technology is the single most important and irreplaceable tool for understanding and interacting with the world beneath the water surface. With the ability to either transmit signals, active sonar, or listen to existing sounds. Passive sonar. Sonar allows us to effectively see through the ocean, supporting safe navigation, accurate shape mapping, fish detection, and maritime defense operations. Although sonar face certain limitations due to factors such as water temperature, salinity, and underwater noise, continuous technological advancement are helping to overcome this challenge. As a result, sonar remains a critical technology in ocean exploration, scientific research, and national security, and it will continue to play an essential role in safeguarding and understanding our oceans in the future. Thank you.
That brings us to the end of our presentation on sonar technology.
Thank you very much for your time and attention. Bye bye.